Hello. Today we are going to go over the notes over 18.1 to 18.3. And even though it's 3 different lessons, really all as one station, it's all about multiplying polynomials, which you'll see kind of really goes back to some of the stuff that we've done previous. We're just kind of combining parts together. We've done some of these recently as problem of the day, so if you're just now watching these, then maybe you'll start to kind of see where some of this is coming from as we've done it again as problem of the day recently. So multiplying monomials first. Remember from station 1, monomials, the word mono means one. So here we're going to just start off, and in this first part, this first slide, is really kind of reviewing our exponent properties that we did back at the end of January, beginning of February, because we're just multiplying numbers and variables, or variables with exponents. So if you remember, back to that exponential chapter, when we were multiplying terms, we're multiplying the coefficients, but we add the exponents on like variables. So if I have multiple variables, if I have x's and y's in the problem, then I just add the exponents on the x's and I add the exponents on the y's. So then here in this case, in this first example here, if I had 6x cubed times the negative 4x to the 4th. So I'm going to just multiply my coefficients, which in this case my coefficients are just the negative 6 and the positive 6 and the negative 4, which would give me, sorry, I didn't mean to use the highlighter there to write. Let's go back to our markers here. And I would get negative 24 from multiplying 6 times negative 4. Then I can go and I can do my variables. I only have x's in this case. And just as we set up here, if I'm multiplying these terms, which I am, there's multiplication here between the two of them, I'm adding the exponents. So here I would get x, 3 plus 4 would give me 7. So if I look at this next one, if I take, again, I'm going to take my 5 times my 7. Those are my coefficients. So 5 times 7 is going to give me 35. And now when I go to look at my variables, now I have multiple variables. I have x's and I have y's. So I'm going to do just the x's first. Now, in this case, those x's have understood one exponents. I've seen some students here, even this year in class, as they've done this lesson, it's helping them tremendously to put those ones there. So if you're one of those people that are going to forget that there's an exponent of 1 there, go ahead and write it so that you actually physically see it. And then if I do x times x, both of them have 1s, and so that's going to give me x to the 2nd power, because the 1 plus the 1 does give me the 2. And then last I have my y's that we have to deal with. And so in this case, again, there's y squared, but there's an understood 1 here on this second y. And so then when I add those together, 2 plus 1 gives me y to the 3rd, and there's my answer. So I would suggest to you to try to go through and do this third example. I would pause the video, take a minute to try to do it, just as we've done some other times. Try to do it on your own. See if you can get the right answer, and then move on. If you did not get the right answer, you can stop, ask me questions, and then you can move on after that. So again, pause the video, try this third example on your own. Hopefully you did that and now you're back. So in this case, I would have taken 3 times 18. That would give me 54. And now I can do my variables. So I just start here. Oh, here's a y. And so now I'm coming over here. Here's the y. So y to the 6th, y squared would in this case give me a y to the 8th power. Now I'm going to look at my next variables. Oh, the next one there is x to the 8th, or x to the 3rd. Here's my x to the 8th. I'm adding those together, so I would get x to the 11th power. And then last, I have, here I have my z Here I have my z to the 4th. And so again, there's an understood 1 exponent on that first z. So here I would get z to the 5th power. It doesn't matter which order your variables are in. A lot of people like to go alphabetical order. So sometimes you might see this answer as 54 x to the 11th, y to the 8th, z to the 5th. I would accept either one of the answers as long as you have the right exponents. So that's kind of review. We did that exponent review back in exponentials, but it is important to remember those rules because it's going to come to play here when we're multiplying a monomial by a polynomial. Remember, poly, if I look here, poly just means many. And that's what I'm doing. I'm taking a one-term monomial by a polynomial. And the biggest key word to truly remember is this word distribute. That's really truly what we're doing through most of this lesson is we're just distributing. So we're going to use the same rules as the previous slide when it comes to the exponents. When I look here at this first example, I'm going to take this term that's in front of my parentheses, that 3x, and all I'm going to do is I'm distributing it to every part of that problem. Okay, so in this case, if I do the 3x times the 3x squared, again, for some people, it's helping them a lot to put that understood 1 on that x that doesn't have an exponent. And so then I'm just doing 3 times 3 gives me the 9. X times x squared. I'm adding those exponents so I get x to the 3rd. Now I'm going to multiply my 3x times the 6x. So 3 times 6 is 18. Again, understood 1s on both of these x's, so x times x is going to give me the x squared. And last, I'm going to do this x, or 3x times the negative 5. 3 times negative 5 is negative 15. Since there's an x there in the front, it's negative 15x. Because this is an x cubed, this is an x squared, and this is an x. There is nothing else I can do to this problem. I can't combine anything together. That's just my answer. Okay. So what about if you have multiple variables? It's still the same idea. I'm going to take this 2a squared, and I'm just going to distribute it to every single part of this problem. So now when I go to do this, I'm going to go ahead and just put my understood 1s on these variables that don't have any exponents. Again, some people I'm seeing that's helping them tremendously. If you think it'll help you, put them there so you can see them. I'm now taking 2a squared times 5b squared. 2 times 5 is 10. A squared, b squared. Because a and b are different variables, can't multiply them together, so it just is a squared times b squared. Now I'm taking 2a squared times 3ab. 2 times 3 is 6. A squared times a to the 1st would be a to the 3rd, but there's still that b there. So this is going to be a to the 3rd b. Now I'm taking, Now I'm taking my 2a squared times the 6a. So 2 times 6 is 12. And a squared times a, again, 2 plus 1 gives me a to the 3rd. And last, 2a squared times 1. 2 times 1 is just 2. And I keep the variable the same, so it's 2a squared. There's my answer. Okay, so take a minute, try the 3rd one on your own, pause the video, try it, and see what you get. Okay, hopefully you took my suggestion, you pause the video. So if I did this, check your answer, you should get 10a cubed y squared, because there's understood 1s on all of those, on all of these variables. I'll go ahead and put them all in there so you can see them. So now when I do 2xy times 3x squared y, 2 times 3 is 6, x times x is x squared, y times y squared is y to the 3rd, plus 2 times 7 is 14, x times x is x squared, y times y is y squared. Some people might think these first two terms you might be able to combine together, but look at them, x cubed, x squared, and y squared, y cubed. So like the numbers are flipped, and therefore I'm not allowed to combine them together. The variables would have to be exactly the same to be able to combine them together. Okay, so the next thing is what we call multiplying a binomial. Remember, binomial meaning two. So I'm multiplying a two term times a two term. And if you'll see here, I have 1, 2, 1, 2. So that's why this is a binomial times a binomial. There are two different methods. I think the method that most students like the most is just sticking with what we know, and it's what's called distribute. Now, because this method or this concept is used a lot in math, you see it come up a whole lot in Algebra 2, even in geometry, and even in more advanced math. A lot of math teachers, there was a way to remember, kind of like Please Excuse My Dear Aunt Sally or PEMDAS, one of those kind of tricky ways to remember something. Somebody came up with a way to remember this called FOIL. I will show you FOIL. I want you to see it and know that this is called FOIL even when you're distributing, because a lot of the times math teachers, and I'll be honest, I do it in my Algebra 2 class a lot, I'll just say, oh, that's a FOIL. Go ahead and FOIL that. So you need to make sure that you hear that term, because I'm sure some of your teachers will say it in the future. So in this case, what I'm doing is I'm taking this first term, this x squared, and I'm going to stick with distributing first, and then I'll show you FOIL. X squared just means I'm taking this, or I'm sorry, distributing it to both of the terms in the second set of parentheses. Then I'm going to take the second number in the first set, which in this case is the 5, and I'm going to distribute it to both things in the second set of parentheses. So let's start here with our first term, x times the x. Again, both of these have understood ones on them. So x times x is x squared. And this is one you're going to kind of want to, you're already probably noticing that anytime I take any variable times itself, or any variable. So if I do a times a would be a squared. Okay, because again, both of them have those understood ones on them. So you're going to see that a lot. X times x is x squared. That's another one that we see a whole lot. So x times x equals x squared. So that's kind of just something to kind of memorize almost. That will help you tremendously. So now I'm taking this x times, so this x here times, I'm distributing it to the second number, which is the 2. So 2 times x is just 2x. So now I've distributed the x to the both parts of the second parentheses. Now I'm taking the 5 times both of those. So 5 times x is 5x, and 5 times 2 is 10. You'll notice what's different from the last slide is that here we would ask ourselves, is there anything there that I'm allowed to combine together? And there happens to be. In this case, if you'll notice, I have a 5x and I have a 2x. And so I am allowed to combine those together to give me 7x. 5 plus 2 is 7, and I just keep the x the same. Now, there's nothing else to combine together, so all I'm doing is I'm dropping down the x squared, and I'm dropping down the 10. So that's going to give me x squared plus 7x plus 10. And there's my answer. So let's look at this next example. And I'm going to show you something that we call FOIL. Okay, FOIL, the first number or the first letter in there stands for first. I'm looking at the first two things in each of the sets of parentheses. So for the F, okay, here's my first and here's my first. So here's where I'm going to do my F. That's my F. Now, O stands for outside. So in this case, I'm looking at the problem as a whole. Okay, and when I look at that, I'm asking for the outside two numbers. Well, in this case, the outside two numbers would be the 2x and the 3. So I'm multiplying those two together to give me my outside two numbers. Now, my next one is I. If O stands for outside, I stands for inside. So again, in inside, I'm looking at the problem as a whole, and I'm asking myself, what are the inside two numbers? And in this case, my inside two numbers are the 4 and the x. So I'm multiplying these two together to give me the inside two numbers. And then finally, if F was first, then L is last. And so in this case, we're looking at this problem and we're looking at the last two numbers in each parenthesis. So here's the last number in the first parenthesis, here's the last number in the second parenthesis. And so in this case, that's my L. So it's just another way of distributing, just to help you remember to do first times the first, the last times the last, the insides and the outsides, so that you remember that you're doing 4 different multiplication problems. So if I did this one then, first, 2x times x would give me 2x squared. 2x times 3 for my outside would give me a 6x. My inside, my 4 times x is 4x. And then finally, my 4 times 3 would give me a plus 12. Now I'm combining my like terms. My like terms happen to be the 4x and the 6x. That's going to give me my 10x. I can drop down the 12, and I can drop down the 2x squared. There's my answer. Okay, so just again, as we've done several other times, take a minute, pause the video, try these two problems, then replay, see what you get. Hopefully you did that. So if we look here again, it depends, and I don't care if you use the FOIL or if you use the distribute. I find a lot of students like the distribute because it's something we know. So x squared times x is going to give me x to the third. X times negative 5 is negative 5x squared. 3 times x is 3x. And 3 times negative 5 is negative 15. And there's my answer. Because there's nothing to combine. I have a cubed, a squared, a 1, and nothing. So there's my answer in this case. My next one, 3x squared times x should give me a 3x cubed. 3x squared times 4 should give me a 12x squared. Negative 2x times x is giving me a negative 2x squared. And then negative 2x times 4 is going to give me a negative 8x. Here's a case again where I can combine my like terms here in the middle. And so that would give me 10x squared. Drop down the negative x and drop down the 3x cubed. And there's my answer. Okay. So if you truly understood the last slide, this next slide is multiplying polynomials. So I have a binomial times a trinomial. I could really make this 4 or 5 terms. I'm not going to do that to you, but the concept is still the same. I am really, and this is why I like the distributive property, or thinking about this as distributing. I'm just going to distribute this x to everything in there. Then I'm going to distribute the 2 to everything in there. Okay, so if I did my x times my x squared, that's going to give me x cubed. So that understood 1 there on the x1 and on the x. X times negative 5x is going to give me a negative 5x squared. And x times 4 is going to give me a plus 4x. Now, if I distribute the 2 times x squared is 2x squared. 2 times negative 5 is negative 10x. And 2 times 4 gives me plus 8. So now if I look, I don't have anything else to combine with my x cubed, so I can just drop that down. I do have something to combine with my negative 5x squared, my other x squared. So in this case, that's going to give me a negative 3x squared. Here, 4x, I can combine with my negative 10x. and that's going to give me a negative 6x. And then I have my plus 8, and there's going to be my answer. So again, pause it, see how you do, try it on your own, and then check your answer. If you need help, let me know. If you don't understand any part of this. So 3x times negative 2x squared is negative 6x cubed. I'm going to distribute the 3x times the 5. That's going to give me plus 15x squared. And 3x times negative 6 is negative 18x. Now I'm going to distribute the negative 4. Negative 4 times negative 2x is plus 8x squared. Negative 4 times 5x is negative 20x. And negative 4 times negative 6 is giving me a positive 24. Now I can, again, go through here. Negative 6x cubed. I don't have anything else to combine with it. I can combine my positive 15x squared with my 8x squared. So that's going to give me a plus 23x squared. Remember to keep the variables the same, exactly the same when you add. It's only when you multiply that you add them together. I know that's confusing. It's really, I'll kind of write a note over here off to the side. But negative 18 plus a negative 20, a negative 18x plus a negative 20x is going to give me a negative 38x. And then I can drop down the plus 24. And there's my answer. Okay. So kind of what I was just saying, when we add, we keep variables and exponents the same. Okay. When we multiply, we add exponents on like variables. Maybe that'll help you keep it straight, keeping that note down, because I can see why that's confusing. It's like when you add, you keep, but when you multiply, you add. So, okay, one last thing, and these are special cases. And when I've been teaching people in class that have gotten to this lesson before I had the video done, the question I keep asking them is, what does something squared mean? So as an example, if I did, if I asked you what 4 squared means, not what the answer is, but what does that squared, what does that exponent mean? Hopefully you would have said to me that that means 4 times 4. So it means that I'm taking whatever the base is, which this is the base part, and multiplying it times itself, multiplying it twice. And that's the same idea here in this case, is if I have a squared outside of the parentheses, lots of people think, because we did it when it was a monomial, think that I can just distribute that square to both of those. But because of the addition and subtraction, you cannot. And this is the key thing for this lesson. You must write it out twice because it means that we have 2 of them. Okay, so here's the example I gave you. If we had a minus b squared, you have to write it as a minus b times a minus b. Then it just becomes, now it just becomes a distributor FOIL, whichever method you liked there of multiplication. So you cannot just distribute the exponent. That is key. I tell students every year with this lesson, you cannot just distribute that squared when there's plus or a minus in there. Okay, this is huge. So in this case, when we go to solve this one, if I give you x plus 4 squared, the very first thing, seeing that x plus 4 and seeing this squared here outside, very first thing you should do is rewrite it twice. So I'm rewriting it as x plus 4 times x plus 4. Now, what I'm going to do is now it just becomes that distributor FOIL. So now I'm just going to take, oops, sorry guys, I moved the There we go. I'm not sure what happened there. Sorry. Now I'm taking this x times x, I'm just distributing x or foiling, whichever way you want to do it. X times x is going to give me x squared. X times 4 is going to give me a 4x. Now when I go to distribute the 4, some of you are going to say, but I just got that. Well, yeah, you do. You get it twice. So I'm going to have another 4x, and then 4 times 4 is going to give me a plus 16. So now, oops, sorry, just clicking on the wrong thing. I'm trying to give myself more space here. Now, when I wanted to go to combine my like terms, 4x plus 4x is 8x. I still have my plus 16, and I have my x squared, and there's my answer. Okay? I cannot stress it enough that when I have that squared, or when you see that squared outside as my exponent outside parentheses, you must just get into the habit of rewriting it twice. So that's 3x minus 2y. And I think then, guys, it becomes easier because if you're getting the hang of that distributor FOIL, now that's all this is. So 3x times 3x is going to give me a 9x squared. 3x times negative 2 is going to give me a negative 2xy. Negative y times 3x is going to give me another negative 6xy. And negative 2y times a negative 2y is going to give me a positive 4y squared. Again, I'm going to ask myself, is there anything I can combine together? In this case, I can combine those middle two, which would give me a negative 12xy. Don't add the exponents. I'm adding, so I keep them the same. Drop down the 4y squared and drop down the 9x squared. And there's my answer. Okay, so we're getting down to the end. We're getting really close here, so I would suggest trying C there on your own. See if you can do it, see if you can get the right answer, and then we just have 2 more here at the very end. Pause the video, try C on your own. Okay, hopefully you did that, and if you, the very, very, very first step you should have done as soon as you saw this problem and saw the squared is write it as 6x minus 1 times 6x minus 1. Now it becomes distribute. 6x times 6x is 36x squared. 6x times negative 1 is a negative 6x. Negative 1 times 6 is another negative 6x. Negative 1 times negative 1 is a positive 1. Now combine your like terms. In this case, my like terms are the negative 6x. So I'm going to get 36x squared minus 12x plus 1. And there's my answer. There's one other special type, and I'll be honest, guys, if you don't recognize it, it's not a big deal. The only thing is, and it does kind of throw some students off, because when you do these, the 2 middle terms, the ones that you are allowed to combine together, they will cancel out. Because if you notice, when I look at this problem, I have an x and an x. I have a 6 and a 6. The only thing that's different is here, one's a positive 6 and one's a negative 6. So that is going to have an effect on my problem. But to be honest, this just becomes distributing. Still just distribute. So x times x is x squared. X times negative 6 is negative 6x. 6 times x is a positive 6x. And 6 times negative 6 is a negative 36. So when I go to combine my like terms and I look at this and I say, oh, there's my 6x's. One's a positive 6x, one's a negative 6x. Oh, wait, that means they're going to cancel each other out. That's 0. And so then I'm left with just x squared minus 36 as my answer. So lastly, if I do this one, x squared times x squared, remember I'm multiplying, so I'm adding my exponents. So x to the 4th, x squared times negative 2y would be a negative 2x x squared y. If you wrote it as 2yx squared, that would be perfectly fine. Here, 2y times x squared would be positive 2x squared y. And last, 2y times negative 2y is going to give me a negative 4y squared. When I go to combine my like terms, here's my like terms in the middle. Negative 2 plus positive 2. Oh, that's 0, so these cancel out. And I'm left with an answer of x to the 4th minus 4y squared. And there's my answer. Okay, try the HMH, try the worksheet, one of the activities, one of your homeworks, whichever one you like. And if you have any questions, please ask.